We're balancing redox reactions. We want to first determine the oxidation number of the relevant atoms. Oxidation number of the monatomic ion copper 2 plus is 2 plus. Titanium 3 plus is 3 plus. 1 plus. We can use algebra to determine the oxidation number of titanium in this ion. Alright, and down here we show where we calculate the oxidation number of titanium. The sum of the oxidation numbers has to equal the net charge. The net charge here is plus 2. So we step through the algebra and we see the oxidation number of titanium is plus 4. We've connected up those things that are changing oxidation number. Now before we worry about the number of electrons, we make sure that the atoms changing oxidation number are balanced. So 1 copper, 1 copper, 1 titanium, 1 titanium. Now we can go on to worrying about electrons. Our rule is that there's 1 electron involved per unit change in oxidation number. We look at copper. Copper is being reduced by 1 unit, plus 2 to plus 1. Therefore, we know that there is just 1 electron involved in that process. For titanium, titanium is changing by 1 unit. It's being oxidized by 1 unit. So we know that we're losing 1 electron in that process. So to balance electrons, we use small whole numbers to make sure the number of electrons lost equals the number of electrons gained. So we see that we are gaining 1 electron in this reaction here. We're losing 1 electron here, so our electrons are already balanced. We don't need to change any coefficients. Now we consider the charge of the overall reaction. We know the net charge on the reactants has to equal the net charge on the products. Before considering any H+, we see that the net charge on the reactant side is plus 5, that on the product side is plus 3. To balance charge, what we have available is H+. So in order for this reaction to be balanced, we need to have 2 H+ ions. And that allows us to balance for charge. The very last step is to balance this reaction for oxygen atoms by adding water. We see on the product side there's 1 oxygen atom, so we only need 1 oxygen atom on the reactant side, so just 1 water. As a final check, we can make sure that the hydrogen atoms are balanced. We have 2 atoms of hydrogen here in the reactants, 2 hydrogen atoms in the products. We're done. We're balanced. Our redox reaction is balanced both for charge and for mass. First step is to determine the oxidation numbers of the relevant atoms. For uranium, we know that the sum of the oxidation numbers has to equal the net charge. The net charge here is 2. We have 1 uranium atom, 2 oxygen atoms. Oxygen, we know in almost all compounds and ions, is going to be minus 2, so we're going to substitute that value in and solve for the oxidation number of uranium. So we yield a plus 6 for the oxidation number of uranium. Remember, I put these in circles so I remind myself that this is an oxidation number, not a charge. For tin, the oxidation number on the reactant side is plus 2. It's a monatomic ion. Its oxidation number is going to be equal to the charge on the ion. Uranium in the products has an oxidation number plus 4, and tin in the products has an oxidation number plus 4. We connect the atoms that are changing oxidation number, uranium and uranium, tin and tin. Before we worry about the number of electrons, we want to make sure those atoms that are changing oxidation number are balanced, and we see that they are. Uranium 1, tin, and tin. So now we can go on and worry about the number of electrons. Every redox reaction has to be balanced for electrons, meaning that the number of electrons lost must equal the number of electrons gained. And we see in this problem that even if we don't change any of the coefficients, the number of electrons lost is equal to the number of electrons gained, because uranium is going to be reduced by 2 units, tin is going to be oxidized by 2 units. As a last step, we're going to balance the charge. And since we see that we are in an acidic solution, we can tell that here, we are in an acidic solution, so what we're going to use to balance charge is H plus ions. On the reactant side, we have 1 plus 2 ion here and 1 plus 2 ion here, so a total net charge of plus 4. On the product side, we have a plus 4 and a plus 4 for a total charge of plus 8 thus far. So in order to balance this reaction for charge, we're going to have to add H plus ions to the reactant side, 4 of them. So now we see that our charge is going to balance out. Now we're going to worry about oxygens. We see on the reactant side we have 2 oxygens, so we're going to need 2 oxygens on the product side. As a final check, we'll check on our hydrogens. We see that on the reactant side we have 4 hydrogens. On the product side we also have 4 hydrogens. Our redox reaction is now balanced both for mass and for charge. We're done.